right. Come over here, go away, go. Da, da, da. Perfect. All right, before I jump into what we're doing today, any questions, anybody? Anything from the homework? Anything? Good? All right. Well, we're just going to jump into today's lesson. Again, whatever we're doing today, not on the exam. All right. New topic, new topic. So, real quick, how do I do this? I have 7 over 15 plus 5 over 12. Yeah. What's not showing? Oh, what the hell? That's weird. I'm sorry. Give me 1 second. All right. So I got 7 over 15 plus 5 over 12, right? How do I do this? Perfect. That's it. All right. So what's my LCD? Remember I said how to do that? Take the biggest number and just keep increasing it until you get the a number that the smallest one can go into. So let's say I have 15, right? Does 12 go evenly into 15? No. So double it. 15 times 2, that's what? 30, right? Does 12 go evenly into 30? Hmm. All right, times 3, right? So now we have what? 45. Does 12 go evenly into 45? Hmm. Times 4, right? Now I have 60. Does 12 go evenly into 60? Good. All right. So we know that 15 times what number gives me 60? What? 4, right? Good, right? So what I do to the bottom, do to the top, and 12 times 5, good. What I do to the bottom, I do to the top, right? A little bit of math. What's that? 7 times 14, call that 28. Plus 5 times 5, 25. Over 60. Oh gosh, this is the hard part. What's 28 plus 25? So like 48, or like 50 what? 53, right? Over 60. And that's it. That's my answer. Questions on this, anybody? It's not bad, right? All right, let's keep it moving. I didn't mean to do that. This is a fun example right here. So I got 4x squared times y to the fifth power, all raised to the third power. How do I do this? Hmm? I'll take that. Yeah, that's it. You're right. So if good. What's that like? I'll take that. 64. Very good, right? Very good. And that's my answer. Mhm. Very good. Questions on this, anybody? So whenever we raise a monomial to a power, every item in that term gets the power individually. All right? That's it. Understandable? Okay. Let's try another question. Ooh, this one is a oldie but a goodie. Mhm. Yeah. How about this? So I want to simplify 5 raised to the negative 3 power. How I do this? Very good. And then what is 5 to the third power? Yeah. Well, say it again. Good, good. That's it. Yeah. Questions on this? Anybody? Okay. So whenever you have a negative exponent, you have to throw it down into the denominator and make it positive. So it's illegal for me to have negative exponents. So that's how we get rid of it. Just put it in the denominator and make it positive. Mm. And then the 125 is just 5 to the third power. So 5 times 5 times 5. That's it. All right. So let's look at what we're getting into today. This is going to be really cool. So, whoops, didn't mean to go that far. Oops. Yeah. Okay. This is what we're doing today, right? So we're going to be simplifying expressions with a raised to the 1 over n power, right? So rational exponents are another way of writing expressions with radicals. When we use rational exponents, fraction exponents, right? We can apply the properties of exponents to simplify expressions. So the power property for exponents says that a to the m power raised to the n power becomes a to the m times n power. When you raise a power to a power, you multiply the exponents, right? Same thing. So when m and n are whole numbers, let's assume we are excuse me. Let's assume we are now not limited to whole numbers. Suppose we want to find a number p such that 8 to the p power raised to the third power is equal to 8. We will use the power property of exponents to find that value of p, right? So 8 to the p power raised to the third power is equal to 8, right? We can just simply make this 8 to the 3 times p power is equal to 8 to the 1 power. You set them equal to each other, solve for p, and you're done, right? That's the magic sauce. So here we go. So 8 to the 1/3 power raised to the third power is equal to 8. So, but we know that the cube root of 8 raised to the third power is also equal to 8. Then it must be that 8 to the 1/3 is equal to the cube root of 8. And it is. The same logic can be used for any positive integer n to show that a to the 1 over n power is equal to the nth root of a. All right. This right here, very powerful and important. All right. Remember that. All right. That's the sauce right there. Mhm. And of course, just to make me feel good. All right. Let's talk about it again. Right. So rational exponent, a to the 1 over n power, if the nth root of a is a real number and n is greater than or equal to 2, then a to the 1 over n power is equal to the nth root of a. The denominator of the rational exponent is the index of the radical. Remember that, right? The denominator of the rational exponent is the index of the radical. There will be times when working with expressions will be easier if you use rational exponents, and times when it will be easier if you use radicals. All right. In the first few examples, you'll practice converting expressions between these two notations. So, for example, let's take a look. All right. They want us to write these as a radical expression. All right. I'm gonna do the first one and then y'all could do the rest. All right. And tell me what the answer is. So for A, right, I have x raised to the 1/2 power. The denominator of the exponent, right, is the index. So this is denominator 2. So this is a square root of x to the 1 power, right? That's it. That's the answer for A. What about B? I have y to the 1/3 power. What's the answer? Go ahead. All right, so the cube root of y. All right, very good. What about C? A little bit harder. All right, I have z is raised to the 1 over 4 power. What's the answer? So the fourth root of z. Very good. Any questions on this? Anybody? No? We can move on, or y'all need to see another one? Move on? All right, go ahead. It's optional. Yeah, it's optional. Yeah. In the future, though, that's going to become something. So good observation right there. All right, let's go in reverse. So let me do A and then y'all can do the rest, right? So for A, I have the square root of 5y, right? So this is going to become what? Open parentheses, put my radicand inside. This is 5y raised to the 1 over the index over here, which is a visible 2, so to the half power. That's it. What about B? B says they have the cube root of 4x, right? What's the answer? 4x raised to the what? 1 over 3. Very good. That's it. How about C? A little bit harder. I have 3 fourth root of 5z. What's my answer? Go ahead. Not quite. No, not quite. Yeah. What is it? Good. That's it. To the 1/4 power. That's it. Right? 3 is just a coefficient. Right? Like a number in front. So we don't really need, that doesn't really do anything. Questions on this? Anybody? Y'all want to see another one or y'all feel good? Yeah? All right. All right, try this out. Okay. Let's say A. What's the answer? Good. What about B? Good. What about C? A little bit harder. Go ahead. So the 1/4, right? That's it. Good. All right. So any questions on this, anybody? Good. All right. So now this example says to simplify, right? So I had A is equal to 25 to the half power, right? That's the same thing as me saying what? What's the square root of 25, which we know is 5. That's it. How about B? Exactly, right? Yep, you're right. Cube root of 64, which is what? Go ahead. 4, right? What about C? 256 raised to the 1/4 power equals the fourth root of 256. All right. What's the answer? 4. Good. All right. Questions on this, anybody? No questions? Go ahead. Sure. Mm-hmm. Yeah. Yeah, I agree. You can also check your answer. Like like having the fraction exponent or having the radical, you mean? I mean, honestly, as long as you're comfortable with one to get you through everything, then I'm happy, right? Like I'm never gonna tell you like do it this way, like if you have your own understanding and you come out with the right answer, I'm happy, you know? So whichever way you like better, do. Like I'm more of a fraction head, to be honest. Okay. Hmm. Yeah, we have more to do. Yeah. You want another one like this? I got you. All right, try this out. All right, what's the answer we got for A? What is it?
Six.
Good. 36 to the half power is the same as what is the square root of 36. What about B? What's the answer? 2. So that's the same as the cube root of 8. How about C? What is it? We say it again?
Two.
2. Good. So this is like the fourth root of 16. So 2 times 2, 4. 4 times 2 is 8. 8 times 2 is 16. Questions, anybody? Go ahead. All right. I'll show you after class how to do that. Yeah. There is a way. I'm gonna give you guys 2 minutes to try this. I feel like you guys have enough information to understand how to do this one. Wow, that's crazy. Portugal lost to Spain. That's crazy. I think I'd be wrong for laughing if Argentina lost, right? Mhm. Yeah. Yeah. Yo, that was hilarious. They did it to who again? They did it to Ecuador, then they did it to England. But England's was worse though, because Ecuador was just noise. Like for England, they had firecrackers and everything. Hilarious. Yeah, that was genius. Right? Yeah. Uh-huh. Oh, nice. Yeah. Mhm. Yeah. Oh wow. Yeah. Oh man. Good times. Yo, twice. I didn't even see that. Oh wow. Oh, I gotta see that. Yeah. Right. Oh man. I thought they weren't gonna win, honestly. Like what you call it, just because of where the stadium is and the breathing and all that. I thought that they would have killed them, but uh, yeah, yeah, true, 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 true. Yeah, yeah. Nah, but I'm still hoping USA do something. I hope. Yeah. Crowds. Yeah, yeah, yeah. Yo, Scotland was hilarious. They came here and drank out all of the drinks. The only thing they left was Coors Light. Yo, I never even tried Coors Light. Hmm. Yeah, that's amazing. That's amazing. Oh man, like that. I can't even imagine how nice it must have been to be a bar owner. Like I literally ran out of my stock. Like, oh man. All right, let's try this out. Let's try this out. Woo. A, right? I have -16 raised to the 1/4 power. What's the answer? Hmm. Mm, it is that, but we didn't get to that topic yet. Go ahead. Okay, give me another answer for that. No, no, no. So yeah. So it's not real. That's it. Exactly, right? So we can't take, yeah, remember we can't take the an even root of a negative number. That can't be done. So it's not real, right? But yes, that is the answer. Uh-huh. Because it's an even root. Yeah, if it was an odd root, like to the cube root or like to the fifth power, or something, then yeah. Like this bottom number I'm looking at, the four. If that was like an odd number, three, five, seven, yeah, then we could get an answer. But when it's an even power, the insight got to be positive. Yeah. Right. Mhm. Exactly. That makes it negative. Exactly. That's why. That's the actual reason why. All right, how about B? This is negative 16 raised to the 1/4 power. What's the answer? Negative 2. All right, how about C? A little bit harder, right? This is 16 raised to the negative 1/4 power. Hmm? Go ahead. Good. That's the answer. Questions on this, anybody? No problem. It's okay to ask. The 1/2? Okay. So for that one, right? Remember, it's illegal for me to have the negative exponents, right? So I have to throw this in the denominator. So this becomes 1 over the 16 to the 1/4 power, right? Remember that that's the same thing, though, as the fourth root of 16, which is just 2. So 1 over 2. That's how. Yeah. Like 8? Uh, there is going to be a question on that, but I'm not looking for not real. I'm looking for the I stuff, but we didn't get there yet. Yeah, 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 yeah. Like that's like if not Wednesday, like Monday's lesson. Yeah. But cool. Is this understandable or do you guys need to see another one? Good? All right, let's get to the good stuff now. Yeah. This is the really, really, really important good stuff. After this, you could do anything. It's the magic sauce right here. Mhm. All right. So we're going to simplify expressions with a to the m over n power. All right. So we can look at a to the m over n in two ways, right? Remember, the power property tells us to multiply the exponents. And so a to the 1 over n raised to the m power and a to the m raised to the 1 over n power both equal a to the m over n. If we write these expressions in radical form, we get a to the m over n is equal to a to the 1 over n raised to the m power, which is equal to the nth root of a raised to the m power. And a to the m over n is equal to a to the m power raised to the 1 over n power, which is equal to the nth root of a to the m power. Blah, 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 right? Let's recap. So rational exponents, right? A to the m over n. For any positive integers m and n, a to the m over n is equal to the nth root of a raised to the m power, and a to the m over n is equal to the nth root of a raised to the m power, right? This is going to help us answer our questions. This is going to be really, really good, right? So which form do we use to simplify the expression? This is key, right? Don't write this down unless you want to get like 100 and write it down, right? We usually take the root first. That way we keep the numbers in the radicand smaller before raising it to the power indicated, right? And you know I got to do that because I'm not good at math, right? So now, here's what we're going to do. We're going to write with a rational exponent these questions right here, all right? I'm gonna do the first one and y'all can do the rest, right? Let's look at A. So I have the square root, little baby 2 is there, invisible, of y to the third power. This is equal to what? Y to the 3 over 2 power. Everybody see that? Questions on that? All right, what's the answer for B? B is the cube root of 2x raised to the fourth power. This is going to be equal to what? Over 3. Good. That's it. That's the answer. All right, how about C? A little bit harder. A little bit harder. I got the square root of 3a over 4b raised to the third power. What's the answer? Go ahead. 3a over 4b to the, say it again? Not 2/3. 3 over 2. Very good. That power. That's it. What? So the index, right, of the radical, that's the denominator of the fraction. Right? Whatever the radical is, that's going to be the denominator of the fraction. And then the inside power is the numerator. Yeah. Yeah, just a general form. Will we feel good about this, or do you guys want to see another one? I don't know. You want to see another one? I don't. This is easy, you know? That's what I'm saying. The next test is gonna be light. You know, if you guys want to get 100, I'm okay with giving y'all 100. No, no, Thursday is a test. Wednesday, new lesson. Yeah. Just look at the review sheet. Everything that's on the review sheet. Minus the hard questions. Oh, it's in the announcements. There's a review sheet for exam two. Yeah. Yeah. Yeah, not the hard questions, the easy questions. Yeah. Yeah. No, there's some hard questions on the review sheet, but not the hard ones. The easy questions.
What do you mean? What do you mean when you say hard?
So like, like how we're like adding and subtracting rational expressions, right? Like that topic, for example. You see how we always like add and subtract 2? We never add and subtract 3. 3 is hard. Like there's like 2 terms.
And top, you need to divide everything by the bottom thing.
No, but I'm saying like there's always 2 terms that we're adding. We never add 3 terms together. But that's, you see that on the review sheet. So there's something like that. That's hard. Only the easy stuff. All right, so remember that a to the negative n power is equal to 1 over a to the n. The negative sign in the exponent does not change the sign of the expression. Remember that. All right. So let's try this out. Oh, baby. All right, let's do this. So they want to know what is 125 raised to the 2 over 3 power, right? I'm going to do this first one, right? So the easiest way to do this, right? Use the index, right? So find the cube root of 125, and then whatever answer you get there, then you square that, right? So the cube root of 125 is what? 5, right? So this inside is just 5 to the second power. Now 5 to the second power is what? 25. And that's it. That's my answer. I'm done. Easy, right? Good. So walk me through how to do B. B says 16 raised to the negative 3 over 2 power. Very good.
On.
Not the cube root. More simple than that. The square root and then cube it. Hmm. Very good. Which is good. Questions on that? Easy, right? Let's try C. Now C is a little bit harder, but not impossible. That's the negative 2/5 power. So what does this become? Tell me what to do. All right, uh-huh. So the 2/5 power, good. Which becomes what? 1/5 root 32 and then squared, right? And then what's the fifth root of 32? 2, very good. Now this is real hard. Y'all might need your calculators for this. What's 2 to the second power? 4? All right. That's it. Questions on this? Anybody? Feel good? What's the hardest question on your homework? This stuff. And then just to make me feel good, let's try another question. I'll put it back. I'm just trying to blow this up first. There you go. So try that out and then we'll see. All right, let's try this out. Whew. How we do A? This is negative 25 raised to the 3 over 2 power. Go ahead.
Index week or house.
So negative square root 25 to the third power. Now this is good. Whoops. To the third power. Negative 5 to the third power, which is what? Very good. Questions on this?
Um,
Hmm? Sure. So in A, that negative, think of it as like a coefficient. It's just some extra number on the outside. So it just makes it when it's not in the parentheses, it's outside, right? Exactly. Mhm. So how about B? I have negative 25 raised to the negative 3 over 2 power. What do I do here? Mhm. Go ahead. Okay.
This, sorry, quickly, anything is important, okay,
Okay.
one under, or one over, two with the index, house, negative 25.
Very good. 25 to the third power, but the negative, right, is on the outside. All right. And then same thing. This becomes negative 1 over, what's this, 5 to the third power, which becomes negative 1 over 125. All right. Questions on this? All right, let's try C. C is a little bit different. C is negative 25 raised to the 3 over 2 power. So what should I do? What? Not real. Very good. Right, because it's in the parentheses, right? And the index is even, right? And I can't take the square root of a negative number, so it's not a real answer. Right? Yeah, right. So questions? Anybody want to see another one? Or are we good?
Okay.
Yeah. True, true, true. True, true, true. Huh? Yeah. Yeah, that's pending. That's coming. All right, just let me give y'all a little bit of notes real quick. Just bear with me for a second before we do another example. So now we want to use the properties of exponents to simplify expressions with radical exponents. So the same properties of exponents that we have already used also apply to rational exponents. We will list the properties of exponents here to have them for reference as we simplify expressions. So here you go. These are the properties of exponents. So if A and B are real numbers and M and N are rational numbers, right? Fractions, then the product property A to the M times A to the N is equal to A to the M plus N. For the power property, A to the M to the N power, right? When you raise a power to a power, you multiply. It's going to be A to the M times N power. The product to a power property, A times B raised to the M power is going to be A to the M times B to the M. Quotient property, A to the M over N is equal to A to the M minus N, where A cannot equal 0. the zero exponent definition, a to the zero power is equal to 1, where a cannot equal 0, so anything to the 0 power is 1. The quotient to a power property, a over b to the m is equal to a to the m over b to the m, where b cannot equal 0. And the negative exponent property, a to the negative n is equal to 1 over a to the n, where a cannot equal 0. Questions on this, anybody? Believe this is on your formula sheet, so you guys are good. Yeah. But just running through it with y'all. Okay, using those properties, these are the last kind of questions we're going to get into. All right. So let's say for A, right? I have x to the half power times x to the 5 over 6 power. Anytime I multiply, right, exponents, what do I do with them? What do I do with the powers? This becomes what? You add them, right? So this becomes x to the 1/2 plus 5 over 6. LCD, we know that's 6. So I'm going to multiply this by 3. What I do to one side, what I do to the bottom, what I do to the top. So this becomes what? 3 plus 5 over 6, which is what? 8 over 6. So x to the 8 over 6, which we know will be reduced down to x to the 4 over 3. And that's it. Questions on this, anybody? All right, let's look at B. Now, you know, for B, this is z to the 9 power raised to the 2 over 3 power. Anytime you raise a power to a power, you multiply, right? So this becomes what? Z to the 9 over 1 times 2 over 3, right? So multiplying straight across, 3 goes into 3 once, 3 goes into 9 3 times. 3 times 2, the answer is z is raised to the 6 power. Questions on this, anybody? You can't just multiply and simplify as well. Okay. C is a little bit harder. We have x to the 1/3 divided by x to the 5/3. Whenever I divide exponents, what do I do to the powers? What operation? Say it again? Subtract, right? So this becomes x to the top minus bottom, 1/3 minus 5/3, right? And then just go straight across. 1 minus 5, this is negative 4 over 3, right? So now, remember, it's illegal for me to have the radical. Sorry? Oh, yeah, right? It's going to go down in the denominator. So 1 over x to the 4 over 3. I'm okay with you leaving it like this. I would take that as an answer. I know you could do the cube rule, blah, 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 all that, but this is fine. Questions on this? Anybody? All right. Huh?
Could I move a little bit earlier?
Yeah, no worries. I mean, the rest of the class is more the same stuff, so you're already seeing the good stuff right now. So sometimes we need to use more than one property, right? In this example, you will use both the product to a power property and then the power property. So try this out, and then we'll work on that together. All right, let's try this. So I got 27 u to the half raised to the 2/3 power, right? So remember, I want to apply that power to every item in that term. So this becomes what? 27 to the 2/3 power and u to the half power raised to the 2/3 power. Now, for the 27, it might be a little bit more helpful to look at it as the cube root of 27, and then you want to square that answer. For the u, this is kind of simple, right? This is just what? 1 over 2 times 2 over 3. Because whenever you raise a power to a power, you just multiply the exponents, right? So this is going to become what? 3 squared times u to the, let's see, this to cancel to the 1/3. Final answer, 9 u to the 1/3. Because of the 3 squared. Questions on this, anybody? Good. All right, let's look at B. Just bear with me 1 second. I got to copy this. Let me use a different color. Okay. So again, whenever I raise power to a power, I'm going to multiply, right? And I have to do it to every term. So I have m to the 2 over 3 raised to the 3 over 2 times n to the 1/2 raised to the 3 over 2, right? Anytime you raise the power to a power, you multiply. So this is m to the 2 over 3 times 3 over 2, right? Right, that's just one. And then we have n to the 1/2 times 3 over 2. So now we have what? M times n to the 3 over 4 power. And that's it. Questions on this, anybody? All right. Let's just do one more example just to make me feel good, then we could call it. It's going to be real simple and quick so we could go home and cheer for Team USA. Right? USA. Yeah, I can't believe Portugal was. Who? Yeah. They've been winning and all that. Yeah. They even got President Trump cheering for them. Yeah, oh man. I think for the finals, if they go to the finals, Trump might be there. He might come through. Mm. What you mean? This is easy. It's like the easiest question. All right, let's look at this. So for A, right? I have x to the 3 over 4 power times x to the negative 1 over 4 power divided by x to the negative 6 over 4 power, right? Just do the top, then do the bottom, right? Whenever you multiply the exponents, what do you do to the powers? You add them, right? So this becomes what? X to the 3 over 4 plus negative 1 over 4. Over, of course, the x to the negative 6 over 4. So when we add these, right, they have the same denominator, just add straight across. This becomes what? X to the 2 over 4 divided by x to the negative 6 over 4. And whenever I divide exponents, what do I do with the powers? Subtract, right? So this becomes what? X to the 2 over 4 minus the negative 6 over 4. Just like that. All right? Let me go across. Now, a negative times a negative is a what? Positive, right? So this just becomes x to the 2 plus 6 over 4. Call that x to the 8 over 4. Now, what's 8 divided by 4 again? So this is x squared. That's the answer. That's it. Yeah. Not bad, right? Just do the top then the bottom, right? B is even easier than A, right? Yeah. A was a little funny, but B is even easier than that. All right, give me a second to copy this though. I'm gonna do this in red, right? White background, blue, so we'll go with the red, right? Team USA. Hold on, that's just a little too thick for me. Let me try. Yeah, that should be, yeah, that's better. All right, so open parentheses. I got a 16 here. And just bear with me. I got x to the 3 over 4 power times y to the negative 5 over 6. Is 4 over 3? Yeah, I can't read. Thank you, thank you. Yeah, I don't know how I passed kindergarten. So then we got the x to the negative 2 over 3 and the y to the 1 over 6. And all of that is raised to the half power. All right, so here's the trick, right? Do the inside first, then work on the outside. All right? So check this out, check this out. So I still got the 16, right? But whenever I'm dividing exponents, what do I do to the powers? Not multiply, subtract, right? So this is going to be 4 over 3 minus the negative 2 over 3. And then this is going to be y to the negative 5 over 6 minus the 1 over 6. And of course, all of that raised to the half power, right? A little bit of math. What do I get? This becomes 16, right? X to the negative is positive. 4 plus 2, 6 over 3 power. And then y to the, right? Negative 5 minus 1 is going to be negative 6 over 6 power. And of course, that's the half, right? Let's answer this, for lack of a better term. This is going to become what? 16 x to the 2 power times y to the negative 1 power. Of course, the half power right there, right? Take that power, throw it on to everybody. Everybody gets it. Everybody gets it. So what do I have? I have 16 to the half power times x squared to the half power times y to the negative 1 power to the half power. 16 to the half power is what? What is it? Square root of 16, which is what? 4, right? So this is just 4 times x to the what power? I'll give you a hint. This is like 2/1. So when you raise a power to power, not two, you raise a power to a power, you not add, multiply, right? So 2/1 times 1/2 is 1, right? Times y to the -1 times a half. This is just y to the -1/2, right? Now you know it's illegal for me to have negative exponents, right? So this final answer is going to be what? 4x over the square root of y, right? But hold up, hold up, hold up. You know it's illegal for me to have radicals in my denominator, right? So, yeah, huh? They said square root, but it's the same thing, right? Remember that the index, right, is the same thing as the denominator of the fraction. So that's why it's square root. Yeah, you can have it as a fraction, right? But just know I can't have radicals in the denominator, so I have to rationalize. And how do I do that? 4x over y to the half power. But how do I get rid of the radical? By very good. By radical y. But what I do to the bottom, I do to the top, right? So here's my final answer. It's 4x square root y over y. Just because I can't have radicals in my denominator. Not bad, right? Sure. So if I copy and paste this question for the test, we good?
No.
No. Yeah. I mean, usually I just copy and paste the homework. That's all. So that's the original question. The blue is A. You see original question. The blue is A right here. And then the red is B. And you know we doing the blue and the red for Team USA, right? Oh man. I didn't even know Belgium had a team. Yeah, that's what I was saying. Yeah. I didn't even know they had a team. This whole time I thought Belgium was Germany. Yeah.
What's next? Poland has a team?
They might, I don't know. Yo, it's sad. I hope they win though. They say that USA has never gone past 16. So, yeah. So right now they're in 16, so they equaled the best that they've ever done. But I hope so. Ooh, that'd be fire.
First game, what is the countries in the first game? Because I don't really bad one.
Oh, with USA,
For the World Cup.
the first two, the first two. I don't remember.
Just the Mexico. Some other.
I can't remember.
I'm surprised.
Yeah,
Not the. I think moving on.
yeah. I know that they did Haiti dirty. Like Haiti got kicked out mad quick.
Kicked out.
Yeah, for the World Cup.
Like a lot.
Yeah. They were the first team eliminated out of like all 64 countries or whatever. Yeah. Something. Yeah, yeah, yeah. Yeah.
But like some, they feel like have the potential to be a good team.
They do.
Just call them
I
like.
don't know. Can I take this off real quick, you guys? Appreciate y'all. Yeah, right.